Hello everyone, my name is Cristina Cassandra Chavez Aliado from Grade 8 Topal. Today, we are going to explore the beauty of colors of light. First, let us know what is light. Light is a kind of energy that travels in waves. It is made when a matter is heated or gains energy. Excess energy is released, partly as light. Electromagnetic radiation is the name for this type of energy. When you talk about light, we usually refer to visible light, which we can see with our eyes. However, there are other types of electromagnetic radiation that we can't see. The majority of the light we perceive appears to be white. A perfect combination of all wavelengths in the visible spectrum is defined as white light. This means that if I have beams of light in all of the rainbow colors and focus them all on a single spot, the combination of all of the colors will produce a beam of white light. Now, let me explain what the spin spectrum all about. It is to demonstrate that white light is a blend of the spectrum colors: red, orange, yellow, green, blue, indigo, and violet, and to investigate how certain color combinations can produce other colors. So here is my finished product of spin spectrum. Now, let me answer the following guide questions given by my teacher. So for the first question, what are the different colors of white light? These are the different colors of white light: the red, orange, yellow, green, blue, indigo, and violet. It is also known by its acronym, which is ROYGBIV. We can only see these various colors through prism, primarily in a triangular prism, since a prism spreads white light into its different components, wavelengths, or colors. An ordinary triangle prism can separate white light into its component colors, which is referred to as a spectrum. Each color or wavelength making up the white light is bent or refracted a different amount. The shorter wavelengths, those toward the violet end of the spectrum, are bent the most, while the longer wavelengths, those toward the red end of the spectrum, are bent the least. This type of prism is used in certain spectroscopes instruments for analyzing light and for determining the identity and structure of materials that emit or absorb light. For the second question, list the colors of white light in the order of decreasing energy. The first color that I am going to put is color violet. Next, indigo, blue, green, yellow, orange, and red. The reason why I placed first the color violet is because it has the shortest wavelength and larger frequency that made the color having a highest energy, while the red has the lowest energy because it has the longest wavelength and smaller frequency. And for the third and last question, state the relationship among frequency, energy, and wavelength of colors. The energy of a wave is directly proportional to its frequency, but inversely proportional to its wavelength. In other words, the shorter the wavelengths and the higher the frequency corresponds with greater energy. So the longer the wavelengths and lower the frequency results in lower energy. And that is all for today's video. I hope you learned a lot from me. Again, this is Cristina Cassandra Chavez Aliado, leaves an inspiring words from Anatole France that a simple style is like white light. Although complex, it does not appear to be so. See you next time. Bye!